We're going to look today about how we actually perform mathematics on variables. Variables are boxes to store data in, but we can actually take the data out of those boxes, perform mathematical functions on them and put them back in boxes so that we can actually perform addition, subtraction and other items. First of all though, I'm going to go through how we use strings. Strings, if you remember, are a string of characters or text. Now we can perform a certain type of mathematical function on these as well, but it works in a different way to what you might imagine. First of all, I have a form here with just a label on the control, two global string variables, storage box 1, storage box 2. The first thing I'm going to do is just tell it to store storage box 1's contents onto the label. So if I make the program run, it says the word hello. Very simple. If I change this from storage box 1 to storage box 2 and run it this time, it says the word world. Now if I was to write storage box 1 plus storage box 2, it performs a special mathematical function called concatenation, where it joins that string to this string. As you can see, there is a space before the W, so when we press play this time, we get the whole thing in one item. Hello world. If these were numbers inside strings, people can sometimes get confused and think that that will make label1.text equal 2 because you've got numbers in here and 1 plus 1 equals 2. This is not the case. A computer cannot see that a string contains anything other than characters. So although you as a human being can see the number 1 in there, the computer sees it just as a character representation. If we want to start using numbers, we're going to have to first start using a special function called convert. This is only so that we can see things on the screen. We're about to do a lot of mathematics using numbers, but then the result of that we want to then turn into a string so we can actually view it on the screen. So I'm going to start now with two integers. I'm going to make the first integer 5 and the second integer 3. So, just like before, if I add the two numbers together, now the number should be 8. For the purposes of this recording, I think I'll make the font size a little bigger. Once again, the number 8. If I was to subtract the two numbers, one from each other, you end up with 2. If I was to multiply, we use a star to say times the two together, multiply 2 together. But what would happen if I use divide? For divide we use a slash. 5 divided by 3 is not a whole number, but if we take a look at it on here, it is. That's because we are using integers. If I was to turn these into floating point numbers, in this case doubles, we end up with the proper representation. This can be really useful if you want to check between two different items. Sometimes you want to see if a number is odd or even, for example, and you can actually use an integer and double set of variables in combination to do that. As well as being able to display things on the screen, we can perform mathematics. Now I'm adding the two numbers together and putting them back inside the box called storage box 1. That's what that means. So storage box 1 equals whatever the current value of storage box 1 is plus storage box 2, take the result, put it back in storage box 1. As you can see here, the answer here is 8. 5 plus 3 is 8. But if I was to run that same piece of code over and over again, now we would find a higher number, because each time the storage box now contains the new answer. So first of all, storage box 1 contains number 5, plus 3 is 8. So now storage box 1 contains 8, plus 3, 11, goes into the storage box 1. So then for storage box 1 here, we're looking at 11 plus 3, and so on. In this way, you can perform different calculations. You don't have to use variables for every single item in the calculation. I can use direct numbers. I can use combinations. I can use brackets to show exactly which way round I want things. I can come up with different answers based on that. Now you may say the number 3 here doesn't almost sound totally right to you. If we actually work this through, 128 plus 12.7 equals 140.7. We can test that, first of all, by using comments to get rid of our next 2 lines of code. We're then saying storage box 2 equals half this value. Again, we can check what the value should be by changing that to storage box 2 to show us a screen. So it should now equal 140.7 divided by 2, which it does. Next, we are taking storage box 1 plus storage box 2. I'm going to get rid of the divide by storage box 2. Of course I missed my curly bracket off, there we go. We can see it equals 211.05. If we take a look at storage box 2 again, we can actually work this through on a calculator to check our maths. It should be 211.05 divided by 70.35 happens to equal 3. We run it and check again, and we are correct. Why was it important to check these sums and maths using a calculator and check it through in our head as well? As I've said in my previous video, doubles don't always give the exact right answer, and a series of stepped kind of calculations such as this one, you cannot rely upon doubles to get the right answer. Any small error that may have been introduced at one part could get bigger and bigger as the calculation goes through. For example, if I was to make this calculation a bit different, the answer is still 3 on this one. we take a look at storage box 1 equaling 140.6, and yet it's coming up with an error when I have it just as 12.2 minus 12.3. Luckily that error has been rounded out, but in some cases it may not have been. How can we make sure they don't end up like that? We can use decimals. Now here we need to, again as before, make sure we tell the computer that we are deliberately using these decimal numbers. Again, the answer should be 3 in this case. Again, the answer is only 3 because of rounding. This minus 0.1 has actually made a change to the numbers that have been used here, and yet the difference hasn't actually come through in the answer.